Good morning. Welcome to readers of A Manufacturing News and members of the Australian Manufacturing Forum LinkedIn group. I'm Peter Roberts. I'm your host today for our webinar on Australian manufacturers reinventing themselves. This time the subject is new insights from old factories. The focus today is on the use of IoT devices to collect data from existing machines, how they can share that data with an ERP system, and how connectivity can create fascinating new machines. Our latest webinar is brought to you with the support of Fusion 5. Fusion 5 provides business software solutions and services that support you and your business in turning potential into reality. Working with global technology leaders such as Microsoft, Oracle, IBM, and Workday, Fusion 5 partnered with Australian and New Zealand manufacturers of all sizes. They work to increase operational efficiency, create people-centric cultures, strengthen customer relationships, and plan better for the future. By modernizing and optimizing the tools, systems, and processes you use, Fusion 5 delivers outcomes that genuinely improve your business. We're joined today by an executive from Fusion 5, as well as two Australian manufacturing leaders. We're going to find out how manufacturers can evolve to stay ahead of rapid change, and how one manufacturer leads the way in connected machine systems. But first, let me introduce our panelists. Joining us today from Fusion 5 is Tom Veach. Tom talks with manufacturers every day, helping them implement ERP, enterprise software solutions. Tom is Fusion 5 Industry Director, Supply Chain Management Operations, and he'll take part in the panel discussion. The first of our two panelists from manufacturing is Charlotte Morris, Program Leader, Industry Capability Development for DMTC Limited. Formerly known as the Defence Materials Technology Centre, DMTC was set up to foster industrially focused innovation through collaborative research. Now a not-for-profit company, DMTC has broadened its focus to creating Australian industrial capability. Finally is Adam Amos, founder and director of Robotic Systems. Adam is a mechatronics engineer who leads a company that specializes in the design and manufacture of bespoke industrial technology hardware systems. I'd like to first turn to Charlotte Morris of DMTC. Morning, Charlotte. Can you tell us a bit more about DMTC and how it operates?
Sure. Good morning, Peter, and thank you for the opportunity to speak to your members today. As you mentioned, DMTC is a not-for-profit company. We fundamentally manage industrial R&D programs predominantly for defence, but also now broader whole of government areas such as health and national security. We work with university and industry partners to do that, and fundamentally we're about developing best practice in manufacturing and other technologies, and making sure that there's a pathway for that information and knowledge to get to industry so that it can actually generate products and services for our end customers. I manage the...
You had the Industry Capability Program. How does that work?
Well, I was just going to mention my Industry Capability Development Program in particular, which came about. Our core activity are those research collaborations, but we developed, or we understood that out of that we needed to transfer a lot of knowledge and information to SMEs in the supply chain. So we developed the Industry Capability Development Program, which has a framework of focusing groups of SMEs on a particular task and using our subject matter experts to transfer that information and knowledge. And that's how the Smart Enough Factory came about, which I can talk more about later.
You told me, first of all, that some of these companies are pretty basic in their operations, and they see a lot of barriers to adopting this sort of technology. What are they?
Well, I'm not sure they'd like to be called basic. A lot of the companies are actually, I suppose, producing some very sophisticated products for defence, but there are a lot of machine shops out there, for example, with a lot of legacy equipment that, whilst they'd like to be extracting data and information and looking at Industry 4, they're not sure how they can actually do that. And the barriers that they perceive are that it's expensive, so it's going to cost them a lot to invest in solutions to do that, that they might not have the technical know-how, the in-house, and the digital literacy to actually use that information. And also they're just fundamentally busy running their businesses and are not quite sure what the return on investment will be for them to look into it. So we developed an educational kit. We call it a factory in a box, which we provide to our participants to give them a hands-on real life experience of actually recording data. It uses low-cost hardware, low-code software, and particularly open source software, so that it's actually something that they can use and access without having high license fees and so on. And we run a 6-month project with a company using that kit, and at the end of it, they can actually have a demonstrable outcome where they might see information from a piece of equipment or a process up on a screen, and for them, and I see it quite often, that's when the light bulb goes on and they actually understand how using that, how much valuable data they have in their facilities that they can use to make key business decisions, improve productivity, or plug into their quality assurances systems.
So what sort of value is this box of goodies that you give a small company?
The value is in the cost. So to participate in our project, thankfully, because we've been supported by Defence, but also by a number of state governments, the actual cost to participate in one of our projects is only $1,000. But more importantly, the contribution is the time and effort from the companies that are involved. So we do ask them to generate a project team within their business. And obviously we recognise that for a small business to spare people, we do recognise that in-kind support. But it's really important that the business is invested in the outcome, because what we're trying to do is work with them to transfer the knowledge and expertise that they will need to then take their next step on the digital journey. So yeah, it's all about removing those barriers and removing the fear, that perceived sort of fear about using IoT and so on.
This is the art of the possible for a small company that wants to start out. I think you mentioned that to me before. So what's your philosophy there behind that?
Yeah, well, until a company can genuinely understand what's in it for them, you can see why they're not going to spare the time and resources to get involved. But regarding the art of the possible, I mentioned before the light bulb going on. I think a lot of people think Industry 4 is maybe machine utilization, which absolutely it can be. But as I mentioned before, it can be environmental monitoring, so that you can verify in your production process when something is sensitive, and you need to be able to provide that information to your customer, and in particular in defence, that's really important. It can be around job tracking and process. So a number of our examples have been around tracking a job as it comes into the facility. Where is it? Where are the bottlenecks? You can see how long it might be at one station, and then you can get an immediate feedback. So a key element of Industry 4 is that immediate access to information, as opposed to retrospectively. You can generate reports, but often you're looking at them at the end of a week or the end of a month, and by then the problem's happened and the waste and the cost has occurred. Whereas if you use this technology, yeah, you can absolutely get an immediate alert and rectify that problem, and that's one of the key benefits.
Thanks. Tom, I'd like to turn to you now, because I think you've got some examples of companies with zero IoT capacity or zero sensing capacity. Could you give me some examples of what you're seeing in industry?
Yeah, absolutely. Thanks, Peter. Yeah, so I see it quite a bit, and a good example is a little business that I'm aware of that, is a produce yogurt, and they have a production line where the yogurt's going down the line, getting poured into the container. And if they aren't there physically watching that line, a simple mistake or a cup might get stuck. Next thing you know, all the product is going on the ground, and before they realize it, they've just lost a huge amount of income because all this product's just gone onto the ground. Whereas a simple IoT device could actually shut down the line, shut down the process, and alert somebody that, hey, we've got a problem, go and fix it. So yeah, we do see this quite a bit, and that's where IoT can come in and actually really make a big difference.
What's the barrier to these companies adopting an IoT solution, a very simple one like that?
knowledge. They simply just don't understand what the concept of IoT is and how it can support their business. And it's quite common. Is IoT is a big scary, although it's only 3 letters, it's a big scary thing. And it's a worry. You know, they don't know how to implement it. They don't know where to start. But yet when you actually sit down and talk to them, say it's this simple. Yeah, you can see the light bulb going on, and they go, oh, I could put it here, I could put it there, I could do this, oh, I could change that.
So what sort of tasks can you give an IoT device?
It can be as simple as just having a camera watching a line, and if the line stops moving, it can indicate. It can be temperature monitoring. It can be you know, if the container is too full, you know, a level. It can be humidity monitoring. It can be all those things to do with that around quality assurance. It can, yeah, there's a multiple things that a little IoT device can do, and it can be as simply as just a switch that is being switched on and off as an item passes by, and that can be a trigger. So if it stops passing by and there's no more switching, hey, there's a problem. So it can be that simple, and things like that are very, very easy to implement.
I think you've got a robot, a complex robot to show us that actually.
I've actually got a little device here that I've, and this is just one that I've been building as my own demo, and that when you pass your, it comes in contact with a sensor, it flashes and it sends a message off to a cloud service that then says, hey, there's a problem. I've got something in front of me. And it sends an alert. Now it can send an SMS message to a mobile phone. It can send an email. It can then stop a ERP system and the production order from running. And it can do all of those things in a matter of seconds, meaning that you're not getting a loss of productivity and downtime because you can go and fix the problem straight away. And that's based on a microcomputer. And I'll tell you now, that computer that runs that, you know, you're looking only $90 to buy it. That's how cheap it is to run something like that, or get started into it.
So you're gathering some data, whether it's simply take some action. Surely you need to have an ability to use that data.
And that's the key to it. What do you do when that information gets captured? Where does it go? How do you utilize that data? Now, in a lot of cases, it can be just an alert going through to an ERP system. And then once it hits that ERP system, whether it triggers a stop on the production order or the manufacturing run that's currently in place, or whether it's just capturing temperatures of the product that's running through the line at the moment, so that you can go back and have a look and say, well, hey, look, we had a fluctuation in our temperature of the snacks that we were making or deep frying at this point in time. You know, it can monitor all that sort of information and give you data that you can use for your quality assurance or stop a production order.
You do have to have the right sort of ERP system, am I right?
Yeah, it's important that you have an ERP system that has the ability to accept some form of integration. And you know, there's a very common platform out there, which is an OData REST API calls. A lot of the modern platforms support that functionality where you can actually write to it. And those that don't, depending on how they're built, it could be as simple as actually accessing an SQL database in the back end and updating records into it that then presents something on the front end. So there are multiple ways that we can do that.
Don, we do have a couple of questions today from the audience, actually, and one is important here, I think, and perhaps for you. I'm interested in an integrated production planning system with simple, configurable, visual dashboards. That's from a viewer. What would you say to that?
Okay, so yeah, there's lots of options out there. There's lots of applications that you can get off the shelf that are planning systems that give you some form of visualization dashboard that you can then use for your planning. The key is, how do we get the data out of your ERP system into that planning system? And that's where, you know, building a data integration layer is what's required. So creating some sort of integration mechanism so that that data is then presented into that planning application and then utilized to plan forward. So yeah, absolutely. There are lots of them out there. It's more about how do we get that data in between the two systems, with some form of integration.
Thanks, Tom. I'd like to turn now to Adam from Robotic Systems. Adam, I used the word basic before, and erroneously, I'm sorry about that. Nobody is in business today who is basic, but you're at the very other end of the system, the scheme of things. You're designing very complex industrial devices that sense and take actions. Could you explain what Robotic Systems does?
So Robotic Systems is effectively a design agency and a contract manufacturer all in one. And what we do is we work with other businesses to take essentially their business cases for a new product and turn that into a prototype, and turn that prototype into something you can produce. So we've got guys on staff here that are electronic specialists, software specialists, and industrial designers. And we also have a manufacturing team that specializes in making low volume, high value devices. So I guess for the purpose of this panel, I kind of represent the manufacturers, and we run a very specialized manufacturing system that delivers on that. So yeah, I guess kind of to echo what the other guys are saying around tech integration. I think if you're going to remain in Australia manufacturing, I think the future of manufacturing basically looks like there'll be guys that have adopted technology into their manufacturing business, and in 5 years' time, that's all there's going to be. There won't be any the guys that are kind of doing it, the old way, without data, without technology backing them up, are going to be fighting a pretty horrendous battle against those that are. So my approach to manufacturing is that, I don't describe Robotic Systems as a company that is a contract manufacturer that's trying to manufacture tech. I actually say we're a tech company that's involved in contract manufacturing. And I think that's the way manufacturers have got to really be thinking about it going forward, is how can they develop their own systems and processes, whether that's buying other people's stuff or developing it in-house, to essentially amplify their own manufacturing and manufacturing capabilities.
So you produce pretty complex systems, mainly for the mining industry. So how does the work process begin? How do you start a job with them?
It always starts with a crazy idea. Somebody comes to us like a Rio Tinto or Orica or BHP or Bradken, and they say, right, we've got this big sensing challenge that if we had a device that could sense and measure some particular thing on the mine site, whether it be teeth on a bucket or amount of explosives in a hole, that would knock onto some significant financial advantage. And in mining, we're looking always for the 1% optimizations. It's almost never about taking guys out of the seats of trucks, because the trucks, the digging equipment, just one digger uses $10 million a year worth of diesel. Taking a guy out of the seat that earns 200 grand is like, who cares? Nobody cares. What they're looking for always is the 1% optimization. How can we make that machine 1% more efficient? And so it always starts with those sort of conversations. Okay, we've got this inkling, there's something there. If we could do it, what would it look like? And that's where we basically take that business case, work backwards from there to turn into a new tech product that could ultimately be scaled out globally.
So you've got a use case and a challenge there, and you go out on site, do you?
Yeah, we operate. We export currently to nine different countries. We've got guys deployed all over the world at the moment working with our customers, because mining is apparently international. Just because we may be dealing with a head office here in Australia, the whole world is the end customer. So our manufacturing has to support international deployments. So we have to lean really heavily into tech and adopting tech. I think that for all Australian manufacturers, really have to be thinking about what are some of the tools that I can leverage to take my business that's maybe dealing with defence here in Australia, to saying, okay, how can we actually take all that capability and turn it into something that we can do for industry on an international level? And the answer to that is technology. It's not kind of adding more dudes or doing more things, because we've got more of in Australia, we've kind of got a first world labour rate. So the answer is never throwing more dudes at it. It's got to be, how can we get a bigger lever, and tech's the answer.
So clearly, communications technology, sensing technology and communications are central to the devices you make. IoT is important, but you also utilize a lot of other sensing technologies and communication technologies.
Yeah, I mean, we use everything from satellite systems to 4G to good old big long cables. It's the mechanism by which we communicate is kind of just whatever is available. The key is, what are we communicating? And often what we're communicating is very small pieces of information. If we're deploying camera systems in the field, we're often processing all of the image data or sensing data right at the point of collection, because we physically can't move it off the site, and we want to be able to just action it then and there, and then maybe we're just doing reporting. So anybody that's kind of thinking about implementing these sort of, you know, IoT technologies, the amount of data you have to deal with is kind of proportional to the problem you're solving, or it varies problem to problem. It's not every IoT device requires phenomenal amounts of data. There are many ways to skin the cat, and if anybody is kind of looking at it thinking, okay, well, how can I get into this? It seems like it's too overwhelming. The first step is basically having a real think about what it is the information actually needs to be that's coming out of it. And often that's quite simple, and usually the guys on the factory floor know what it is, and they know the answer, and that's how to kind of simplify the problem.
But Peter, sorry, I might just jump in there, because couldn't agree more, Adam, with that. And with our Smart Enough Factory project, a big part of what we do at the start is this project scope, and speaking to the operators and the business owners to understand what their challenges are and demonstrate to them that we've got to find that key bit of data. And Tom, you mentioned it too, like, you don't have to censor up everything. It's what is the problem you're trying to solve, and how do we do that, you know, very simply. And developing that project scope is actually sometimes the hardest part of the project. The actual delivery of the technology is pretty straightforward, although my tech team will kick me for saying that. But yeah, it's actually understanding the value of data in your business. And we're fortunate, we've got business advisors that work with us on our projects that look at it particularly with a defence customer lens, but mining sets a really good example as well. You're kind of the leaders, mining sector, I think, in the use of IoT. And yeah, the take up there has been a lot faster, I think, than in the, I suppose, more traditional defence industry supply chain. Sorry, Peter.
Very good. Thanks very much, Alice. And before we go away from you, I'd like to understand one of the cases that you've worked on, and it's a company that I've often admired, Orica, an explosives company which has increasingly digitized its explosives operations and also developed a explosives as a service business where they have these large bulk master trucks which drive right onto the mine site and pump exactly the right amount of explosives into all these different holes. I understand they gave you a challenge of automating this mine truck.
Yeah, it's not so much the mine truck, but the fragmentation of the blast. So for those that don't know the mining industry, Orica is a big deal in the mining. They sell explosives, lots of explosives. If you ever remember the tragedy that happened recently in Beirut with the big explosion, here in Newcastle, we have more than 10 times the amount of explosives just here on our port that gets consumed on a monthly basis here in the mines. So there is that gives you an idea of the scale. And so Orica sells explosives, but nobody wants explosives. What they actually want is broken rock. This is kind of an example of like, what is the real problem? And so Orica is really concerned about the size of the broken rocks, because the size of the rock dictates how well the diggers dig, how well the trucks haul, how well the crushers crush. And you get it wrong, it knocks onto millions of dollars per day of lost productivity for the mine. So what Orica wanted to do is develop a new type of sensor that they got attached onto the diggers in the mine site. And essentially what it would do is take three-dimensional photos of the broken rock after a blast has gone off and work out how smashed up the rocks are. And so basically what we did, we were tasked with this challenge of how to develop and manufacture a device like that. And so far we've been successful in that. We've produced over 165 units and shipped it everywhere Orica is. Essentially what it does is it closes the loop of Orica's blasting outcome. So there's a sort of tech that is kind of the mining industry is really looking at, because they can see these really phenomenal business cases. Or if you could just measure or sense X, then millions are attached to that. And that principle applies to whatever you're doing, whether you're in a factory or on a mine site. there are often these little 1%ers that exist everywhere that basically, if you can solve that, it knocks onto great business cases. And kind of the rule of thumb I use for the mining industry, and it probably applies in factories as well, is every time I see the dirt move, there's opportunity there. There's a 1% there. And it probably is the case for any product moving around the factory floor. There's probably a 1% there somewhere. And it's really the job of, sounds like Charlotte's team, to actually kind of get in there and find that 1%er. And then the tech is like, it doesn't matter what the tech is. Tech's like simplify. It's nailing that business case first is the main thing.
So you have an enormous array of skills that you're working on: computing, sensing, hardware, software, all sorts of things, and yet you're only 20 people. How do you manage that, Adam?
Well, we've got a good team, so we've had some pretty big growth in the last couple of years, from kind of 4 people to where we're at today, almost 20. And we've got a corporate structure now that's in place. But essentially, the teams manage themselves. So we don't have an oligarch style, structure where there's kind of one supreme leader. The teams are divided up into groups of 4. They basically take a project, take a business case, and turn that into a new product every 4 months. And they do that. And we've got 3 teams that do that every year. So we produce, quite a few tech products each year doing that. So essentially, decentralized decision making.
Okay, well, let's try and understand some other cases that have actually been worked on. Charlotte, one of those basic companies you talked to me about was basically a furnace company, but actually they produce very sophisticated parts. Can you tell me about that example?
Yeah, absolutely. I think they are a good example. And so AW Bell was one of our pilot companies, and I suppose you'd think they're a casting business. They also do machining now as well, but they're an incredibly innovative company. And you would think casting is casting, right? What technology can you introduce into that? But their challenge was around use of energy and electricity costs. So obviously you have to put a fair amount of power into a furnace to get it up to temperature. So when we spoke to them about what were their key problems, they were asking for a way to monitor power consumption and energy usage on their furnace and on their autoclave. So using pretty simple technology, I think it was an electricity clamp, but Tom, you'll have to tell me more about that. But we were able to give them a system which enabled them to visualize their energy use. So obviously they had a sense before, but it was a bit of a, yep, we think we need to up the, this is when we need to boost the power. But having more information meant that they could then select when they actually needed to boost the power and choose whether that was in peak or off-peak time. And they actually had much better control over their energy consumption. I'm pleased to say that Sam Bell, their MD, has quoted that using that information, they actually see that they're going to reduce their energy consumption by over 68,000 kilowatt hours per year. So that's your 1%er, Adam. When you talk about what's save a business, and we're all, and it's not only that, but it's the environmental savings there too. I mean, the less emissions and so on. So, but as I said, AW Bell casting, you'd think, yep, what technology could you possibly introduce to that? But that's just a simple sort of case study of one thing we've done with them.
And I perhaps use the word basic because I have seen quite a lot of basic manufacturers, even very, very recently, including one recently where the work jobs were all on paper, and that the boss's desk had 20 or 30 sheets of paper, each to be given to each worker. And it quite shocked me actually to see that, but I believe you have an example from paperwork production as well, Charlotte.
Yeah, absolutely. So another company that we work with, Redline Engineering, CNC Machine Shop, they're just celebrating 50 years, so congratulations to them. We went into there thinking that we'd be looking at a machine utilization and optimization project, but actually their biggest problem was that the use of paper and the tracking of job cards through the facility. So at each point in the process, there'd be a job card with all the paperwork behind it, but quite often someone else would have kept the bit of paperwork, or it had gone walkabouts, or and there'd be a waste of time and effort and someone having to traipse around that factory and look for all of that information. The other part of it is that people didn't necessarily know where that job card was or where that job was at any one time in the facility. So we actually work with them to digitalize that process. And so that at each workstation, somebody can simply log in using an iPad or a screen and bring up the job number, and then not only pull up the work order, but then find in the database the information that they're looking for. And they've actually gone on to sort of build on what we did was a proof of concept on one piece of equipment. But since the project, they've actually engaged a process engineer to make sure that all that information is now available in a digital form. They've rolled out screens to each of the jobs, the stations on the factory floor, and they've really taken that in leaps and bounds. So we've got to think of, people have got to think of IoT not just, I think, of sensors and machine monitoring, that there's a whole, other wealth of opportunity out there.
It's interesting because I think in the last few years, the switch has happened amongst the workers themselves. We used to think perhaps some of these companies that the workers wouldn't be able to accept this use of devices, but in fact, everybody's using devices now. But Tom, I'd like to flick this question to you also from a member of the public. We're collecting information, proprietary information, and we've got a question: with the connection of older environments to the internet, how do you balance the benefit of improved connectivity with increased cyber incidents?
Yeah, that's a really good question, and it's one that needs to be that's really super important, because cyber activity on the internet is huge. It's massive. We can't turn a blind eye to it. It is something that is really out there. And with any of these integrations to any of the ERP systems and things like that, the security is now at a really high level with multi-level authentication, token security. So it's important that whatever we do with an IoT device, that we provide that security layer on the device and the communication going backwards and forwards. And it's something that, Adam would be 100% aware of. I'm sure even Charlotte, in your industry, we all have to have a focus on what that security layer is and how secure, because it's anything that's on the internet is prone to attacks. It's how we minimize those attacks.
Yeah, especially in our sector, in the defence sector, so much so that we've actually introduced, as part of the delivery of our program, a cybersecurity for operational technology module. So we've teamed with a company called Williama, 100% indigenously owned company who have a significant experience in the defence sector. And really, in our course, we can probably only provide awareness around the additional threats, I suppose, that introducing IoT to your facility can create. But there are a number of ways that you can protect yourself. And sometimes you don't have to actually be speaking to the outside world. You can have it on an isolated network. But it is critically important in all sectors, but especially in ours, in defence, that companies are aware of those additional threats, and we're pleased to be able to provide. We found that whilst the companies were getting a lot of instruction around their cybersecurity for IT, there wasn't much around there focusing on OT. So yeah, we've developed a curriculum to help companies particularly look at that area.
Yeah, and we're very conscious about the technology that we use for that communication layer to ensure that it meets a great security level. So yeah.
Thanks, Tom. I think you've got a couple of examples, very good examples for us, a snack food brand that you worked with. Do you want to talk about that?
Yeah, absolutely. Yeah, so they approached us with a problem. They wanted to streamline their packing process once the product is finished the manufacturing stage. So as it's coming down the manufacturing stage, it gets boxed into boxes and then it goes down a conveyor. And they wanted to then have multiple lines running at any one time, going down the same conveyor. So they introduced a robot, and the robot was purely just picking up boxes, stacking them onto pallets, and it would pack up it would do 6 pallets at a time, and each one can be its own different production run that's currently running. So the challenge was identifying the cartons coming down the line and knowing which production order was running, and then stacking them onto the right pallet. So what we did is we introduced, there was an IoT device that was actually reading the barcodes on the side of the boxes as they're coming down, and then referencing that back to the production order that's running in the ERP system, and then counting through the boxes. Now, when it reached a certain number of boxes and it had gone through and started stacking the pallet, it would then wrap the pallet and then apply an SEC label on the side, and then pick it up and move it out to be put into the warehouse. And essentially, it increased their productivity a huge amount, because all of a sudden they could run 6 lines simultaneously and pack them and wrap them into their warehouse. So, and then they went from having a local warehouse to an off-site warehouse with another third party. So they introduced the whole line all the way through and reduced their costs a lot. And that's a very simple use of an IoT. It's not doing anything like temperature sensoring, anything like that. It's purely just reading the cartons as they're coming along and then reporting back to the ERP where it's up to.
You had a more complex example, also a canned food manufacturer.
Yeah, that's right. Yeah, one of the major can manufacturers in Australia. They run a production line, and they produce, you know, millions of cans of this product a day, and it runs down the line, and the cans are constantly running down the line. There's several things that they do is they check the weight of the can with an IoT device to make sure that it's got the right amount of product in it. As it runs further down the line, it goes in through the ovens and gets cooked. Every stage is being monitored, even to the point that when on the bottom of the can, there's a date that's stamped onto it, it's recorded into the ERP system, and then it feeds into 19 packing lines. And those 19 packing lines are all loaded up, and they go onto the pallets and they're stacked, and then it reports as finished when it's done. And yeah, it runs, you know, we're talking, you know, 500,000 or 600,000 cans of product in a day. It was huge. So, and that was a lot of IoT devices in that.
And what about AI? Is that in use in this sort of area?
Well, we're actually working on a project at the moment where, and it's the use of an AI solution with a manufacturer that make aluminium products. And the problem that they had is when the warehouse worker goes to pick the goods from the rack, if he picks the wrong item and puts it onto the truck, it goes all the way out to the building site, and then has to be picked up and then transported all the way back again, introducing a lot of expense. So with the use of AI and cameras, we're actually going to be watching what the guy is picking with the camera, and if the item that he picks does not represent the item that's supposed to be picked in the work order, it will actually alert him using an AI and saying, hey, you've just picked the wrong item, you need to go back and pick the right one. And that's using AI to analyze that video, which is pretty much what Adam's doing with these buckets when they're picking up the stone. They're looking at that stone and measuring it and all that, and creating a reference and saying, hey, it's too big or it's too small or whatever. So it's using technology to improve the production and the process.
Let's go back to Adam, and you can talk about one of your other more sophisticated machines, Adam, Grease Boss.
Yeah, well, this is an IoT device, so that basically helps with on maybe off the production line or on the maintenance side. So one of our customers are greasing experts, and what they've got is a device that gets attached onto the greasing guns that is then used and carried around by all the maintenance staff. Basically, what it does is a RFID tag is attached to all the greasing points, and as they go around and grease all of the positions in the factory, the IoT device is collecting all that information and then reporting it up to the maintenance dashboard. So the guy that's actually responsible for the factory being maintained can hand on heart say, you know, it's actually happened. So it's kind of IoT in the world of actually on the lines themselves, then also the ancillary supporting processes that go on, keeping the lines actually moving.
So you've got Wi-Fi, RFID, IoT all on the one device.
All on the one device.
And now I'm interested in the LiDAR system. LiDAR works on the principle of radar, but uses reflected light from the laser. rather than radar waves. Tell us about that LiDAR device you've been working on.
So LiDAR is one of those really interesting sensing technologies that allows you to, trivially it tells you the distance from yourself to an object, which sounds pretty boring on its own, but LiDAR gets really interesting when you start combining it with other sensors. So what we're able to do is take a laser that only shoots a single point, put that on a device that spins, so now we kind of get a plane, and then we connect that spinning laser with something that tells us our angles that we're actually firing at, and the position we're at as well. And what we're able to do is create a device that's actually able to take a three-dimensional picture of the world around it as it moves through it. So in free space, if you build a three-dimensional model of anything, of any object, and do that at ranges of up to 100 meters away. So it essentially creates a digital twin of its own surroundings. And so what that allows you to do is take the automation to another level, because now the robot can not only just see an image, but it can see a picture of the world around it as then actually move through that environment in three-dimensional space. So LiDAR is one of those really cool techs that kind of stacks on top of other technologies to then build something really quite special.
I think these are used in open cut mines to display the slopes of the sides and that sort of thing.
Yeah, that is the precursor for all navigation tasks, whether you're outdoors or whether you're in an indoor environment in a warehouse, or your robot vacuum cleaner that you've got in your own home has got a spinning laser system.
So you've got 20 people there. How long does it take you to develop such a device?
So our big claim to fame is that we could take a business case and turn it into something working in the field in 4 months. And we do that very reliably for all industrial products. So we just develop industrial tech. We don't do any consumer tech. And so that's basically our big claim to fame. 4 months to something working in the field.
And that means you're working with a number of suppliers. Sorry, Charlotte. Please go ahead, Charlotte.
No, I was going to brag. I was going to brag about one of our 6 months our projects run for, and our tech team also have to come up with solutions within 4 months. So it's not me.
Yeah, anything longer than that when you're developing tech hardware is it's too long. The amount of error that you get in a project, if you've got a 10% compounding error on tasks, on overruns, then anything longer than 3 months just compounds out to ridiculous overruns. It's like the government running those 5-year, 10-year defence contracts and having a 10-year overrun on a 10-year contract. So yeah, we only run projects for 4 months, which I think is a good rule of thumb for anybody developing tech, is how to get something working in the field within 4 months at the latest.
So you don't actually manufacture anything in a sense. You draw on a large supply chain and do the final assembly, I understand, and the QC. So this is where you've come up with your idea of how manufacturing will look in the future as a diversified system of interrelated parts.
Yeah, that's right. So what I think the future of manufacturing looks like in Australia, if it's going to be globally competitive, is it's not going to be manufacturers having one big manufacturing operation with a broad range of manufacturing assets to trying to keep busy, chip shooters, CNC machines, whatever. It's going to be supply networks of smaller specialist contractors nailing just one part of the supply chain. So whether that's CNC house that just nails doing CNC of one particular type, they'll do it better than anywhere else in the world. Same deal with guys making printed circuit boards. Same deal with where we fit into the supply chain as the final assembly and logistics and QC shop. And I think these networks of smaller, more focused suppliers have the ability to actually outperform international competitors. But it kind of takes a shift in the thinking in Australia for how we approach manufacturing. So yeah, basically we're going all in on the smaller network of manufacturers rather than the big one-stop shops.
Charlotte or Tom, are you seeing that?
Absolutely. So we have developed a community of practice, so we've worked with over 60 SMEs now, and it came about because after we started to run the first cohorts of companies, we realised that there was real value in connecting these businesses with each other and getting them to share their experiences and their challenges and how they're overcoming them. So Tom, you were talking about connecting to an ERP system. That's a common one that we're hearing, and we had one group where 3 SMEs who were all doing similar things. So you might have thought they were competitors, but they actually work together to pool resources and solve the problem themselves. So Adam, I think you're right. We're going to see more of those, companies that are really good at doing that one thing, but they have to work with each other. And we facilitate our community of practice by bringing them together at the large defence trade show events. So we just had Indo-Pacific, and we run an ICD delegate day where we tour these companies around the defence exhibition hall, which can be quite daunting for a lot of the companies who are new into defence. And we're really there trying to get them to talk about what they can do with each other, and then pick each other's strengths and then play to those strengths. And I think that you're right for the future of manufacturing, and in Australia with the sort of unique environments that we face, I think that's absolutely necessary.
And I think to add to that, there is a lot of companies out there that are running very old manufacturing processes or legacy systems or softwares, and they really are struggling to understand what the next step is, where do they go, what do they do, and can they bolt on IoT to their current systems to give them a level of confidence of what they're manufacturing and being efficient and being cost effective. It's all about making sure that your margins are there, that your costs are going down instead of going up, and you're still maintaining the output. And it's all about how do we get those ERP systems. There are some that just can't be upgraded. You just can't go anywhere with them. They need to look at the new solution. But those that can, introducing technology to help them do their job. So.
John, I think there's one element of your work that we haven't quite covered, which was the element of the access to researchers and to students. Do you want to talk about that a little bit?
Yeah, absolutely. So I sort of talked about DMTC's core being in R&D. So working with us on the Smart Enough Factory, we have some brilliant subject matter experts in Industry 4 from RMIT and UQ. But another key part of what we do with the project is use undergraduate interns. So we discovered pretty early on that the SMEs needed some extra arms and legs to help them work through the project. And that's both just from a capacity perspective, but also from that digital know-how and knowledge to help them understand the software within the kit. So it's been hugely successful. So we've run this project in Victoria, New South Wales, Tasmania, Queensland, and each time we use local undergrad interns, generally mechatronics, but also cybersecurity, electrical engineers, mechanical engineers, to work alongside us and the companies to deliver the project. And through that, the companies firstly get exposed to the value of having interns. Secondly, they get to sort of try before they buy, and we've had a number of those interns employed by the companies at the end of the project. But importantly, those interns are getting to see how clever and fantastic Australian manufacturers are, because and they understand that they can actually go on when they graduate to work within the industry in their own backyard, when a lot of them were thinking they were going to have to move overseas, or they're not sure where they're going to be able to apply their trade here. So it's been a really valuable part of our program, and yeah, something I'm very proud of.
Adam, are you working with students and researchers like that?
Yeah, so we've got kind of 2 key partnerships. We've got one with the UTS. We've done a couple of projects with them. We've actually hired PhDs that have successfully completed out of the UTS. And we've also got a partnership with Newcastle University. We basically work with their competitive engineering teams as a feeder for our HR. So working with the unis kind of for a business is, you've got to be very defined in what you want them to do. You can't kind of give them anything too open-ended, because the results just won't be there. If you can be quite concise with the block of research or whatever it is you want them to do, you can get good results. But I'd say that the asterisk here on all of these, if you intend to use university resources, please be mindful that they are academics. They're not kind of in the commercial world. They are there to research, and that is their prime directive. So as long as you can be clear with what the outcomes of the research are, you can get some really great results.
Well, thank you, everyone. With that, we're coming to the close of our webinar, New Insights from Old Factories. We've heard a lot today. We've heard from a collaborative research group helping companies to digitize, DMTC. We've heard from an innovative industrial and systems manufacturer, Robotic Systems. We've heard from Fusion 5. There's nothing left for me to do but thank our panel, Charlotte Morris, Adam Amos, and Tom Veach. Thank you for joining us. And thanks to Fusion 5, who made this webinar possible. Do reach out to them to discuss how to unleash efficiencies in your factory and how they can help. It's goodbye from me, Peter Roberts, and to those watching at the office, many thanks for joining us. With that, I'll close today's meeting. Thank you and good day.